Hi guys, so this is going to be the next sort of fast forwardy tutorial work in progress video. What I want to get done in the next couple of videos is sorting out the way the models for ships are procedurally generated. So I've just sketched up some stuff here to sort of roughly explain how I'm going to go about this. So you see this here, this is how the blocks are currently handled. So you have a 1x1 volume, so a cube, and inside that is a single mesh, which is defining the geometry of the block. So what happens is if you stack those next to each other, you'll get sort of a block, and then a block, and then a block, right? And you have the gaps in between them here. So originally what my plan to do was to have these blocks set up so that there was little linking bits in between them, so that you would get this sort of deal going on, so they looked like they were like cubed together. So what I want to do is sort of improve the way this works, and have it so that these will all get combined together into a single mesh. So the first step in doing this is I've split up the block meshes to have these sections. So you've got corners, edges, and middles, right? And when a block is assembled, it will, if it's a single block, it does a corner on each of the 6 corners, an edge on each of the 8, 9, 10, 11, 12 edges, and then a middle for the 6 faces of the cube. When you put 2 of these next to each other, you'll get exactly the same as what you've got currently, or what we got currently, which is you'll have one block and then another block and a gap in between. So then the next step that I'm working on now is having it so that when you place 2 blocks next to each other, so you've now got a 1x2 space here, what it will do is it detects that these 2 are adjacent, and instead of placing these, it then instead places an additional edge, an additional middle, and an additional edge to make up what is a long cube that's 2 blocks long. And by stacking these, you can then have a block of any size. So this is what I'm going to start with. There is additional things that I do need to add which I've not planned out properly yet, which is if you have this situation where you've got a block, and a block, what it actually needs to do then is, let's grab some different line colour. What it should do then is place this sort of geometry where it's putting in an internal corner. Let's pop the fill on that to that. So you should get this effect, which has this corner in the middle here. So I've not planned out how to do that yet. I've not made any meshes for that. What I want to do to start with is just get it so that it will create rectangular or cubic blocks of any size. So that's what we're going to do. The original ship code basically has a 3D array of integers which have the type of block on each coordinate inside the ship. What I'll do then is we'll put in a function that will walk through that array for each block, and it will get the adjacent blocks, so it'll be up, down, bottom, right, forward, backwards, and then the diagonally adjacent blocks. It will then look at the block ID for the adjacent blocks, and if it's the same block ID, it then needs to generate this mesh in the middle, and it should do that for all of the blocks. So it'll walk through all of the blocks together, adding in the various meshes. And then finally, it will probably not be in this video, it'll probably be in the next video. What it needs to do is then take all of this geometry, merge it all together, merge the points to reduce the number of vertices we've got, so that it works out the index of this point here is the same for this mesh and this mesh. and then it will merge it all together into one single mesh. So other things to think about with this is the shaders. Now, originally the blocks used UV coordinates, and I'm using UV mapping to put the textures on. The way I'm now leaning towards doing this is with vertex color, which gives us a couple of cool things. First off, if you have like the outside of the block is one vertex color and the inside is a different vertex color, we can use that to not only put a different texture or procedural texture on there, but also allow the player to change what that vertex color is so they can decorate their ship. So if you want a bright orange ship with like bright blue details, you can have that. It would look a bit weird, but you know, it's all about creativity and what people want to do with their ships. So what I'm going to do is we're going to go fast forward now. I'll quickly show you the mesh that I've generated in Lightwave to use for this. I've just made a basic kind of rounded corner cube with each of these, like the yellow, the blue and the green edge corners in the middle. And then I'll get into the code and we'll look at how to arrange all of that in space and detect the adjacency. So what we'll do now is we'll switch over to Lightwave, we'll take a look at that block, and then we'll go fast forward and I'll get some code in place, do a bit of testing, and then once that's kind of working, I'll get back in and we can go through the code and see what's going on. So cool, thanks for watching guys, and let's get this done. Okay, right. Okay, so here we are in Lightwave. This is, I'm just calling it a bulk cargo block. The idea is this is like you can build a cargo bay that is whatever size or geometry that you like. I've just mocked this up. This is what we're initially going to try and generate in Unity. So we just want to generate a single block that's made up of the elements that you saw in the previous video. This is orientation, right? You've got meshes that we're going to copy into Unity are the face, the corner, and the edge, and they go together like that. And when generating the single block, what we're going to do is go through for each edge of the block. We're going to put an edge there, there, there. We're going to put a corner in each corner, and we're going to put a face on each face, and then display that in Unity. So that's like the first step that we want to get to. So what I'm going to do is I'll just delete that, go back to saving. I have set different materials for each of these so that we can highlight the different colours in Unity. If I export to FBX, make sure it's ASCII, and press OK, and then bulk cargo block FBX. So what that will do in Unity, which is now importing them, if I go into Asset, Models, Blocks, we've now got this bulk cargo block, and you can see that's made up of the 3 meshes. So inside this we've got that mesh, that mesh, that mesh, and they have materials, bulk cargo edge, bulk cargo corner, bulk cargo middle, and it's actually imported those materials as standard shaders from Lightwave, which is nice, so I don't have to do any setup with that. Oops. So what I'll do is I'll get into the code, do some fast forward, and I'll see you in a couple of minutes. So sit back, chill, enjoy whatever music I find to stick in the background, and we'll see how this goes. Okay guys, so here's where I'm at. I've got the corners and the edges pinned in. I actually didn't do a fast forward of quite a lot of that because a lot of it was just messing around. What I've done is I've added in the text gizmo plugin, and I'll stick a link to that in the comment. So what I'm doing is I'm labelling up each of the positions here, so I can do that for debugging. But what you can see is we've got the corners and we've got the edges now plugged in for a single cube. And then I'll do the faces next. From the code, we're basically creating a new mesh for the entire object. We're creating a temporary mesh called block mesh, and then we're going through each of the blocks, like the key value pairs in our blocks dictionary, which is this one here. And so this takes the coordinates of the block and an integer as the type of block. And so then what we're doing, because we're only dealing with one type of block at the moment, this is all kind of ignored. We're getting the adjacent, which is get adjacent, and at the moment that's an empty function that returns null. What this will do is this will return all of the adjacent blocks of the same type, and we can use that to then work out where our edges are. And then this stuff will get refactored into like draw face, draw edge, draw corner, that sort of stuff. But what we've got here is we're creating a list of vector3 for the vertices, a list of integers for the triangle indexes, and then we're going through. So we're going through all the corners. So I equals 0 to 8. We're going through. We're getting the corner model, which is stored in this block factory. So you can see here I've got lists of models, or meshes rather. So corners, edges, and faces. So it's getting the value from the block dictionary, using that to look up the model that we want. We're then keeping track of how many vertices we already have, because we need that when we're adding the triangles. We're then adding the triangles, so that's basically going through the current block mesh and just copying the triangles and appending them to the end of our triangle array. We're then using the matrix 4x4 offset is the corner locations for this corner, and these are all configured here. So we've got corner locations, edge locations, and face locations, and these are just matrices to transform the position and really actually all we're doing is rotating at this point, to rotate the mesh around to fit into the correct places. So as you can see here, it started with say C0, which is here, and then it's rotated that around 90 degrees around Y to get C1. Oh, sorry, it's rotated it 90 degrees around the Z-axis to get 1, then another 90 degrees to get 2, then another 90 degrees to get 3, and then it's done the same thing on the other side to get 4, 5, 6, and 7. And the same thing is done with the 12 edges. So basically in here what we're doing is we're appending the triangles from the block, from the original mesh, because they're not going to change. Then we're going through each of the corners, each of the vertices for this particular corner, and then appending them to the end of the vertices list. We're then doing that the same for the edges, and at the end we're just taking block mesh vertices, is all of the vertices we've just generated, all of the triangles we've just generated, and finally, rather than doing any cleanup or anything, we're just assigning all of these vertices and triangles into the mesh for the entire model, and then I'm just returning the number of triangles and the number of vertices. So when this is running, you can see it's found 360 vertices, 528 triangles. Obviously we can optimize this a lot because a lot of these are duplicate vertices, so if we take out all of the duplicate ones, this will be a much lower number, and that will be like the final pass before giving the model back to the game, will be to basically merge all similar points and all similar triangle indexes so that we've actually reduced the number of vertices considerably. So yeah, next I need to go in and get the faces and get those done, and then I need to refactor the code to basically take each of these add edges loops and each of these add corners loops and refactor those into add side forward, add side up, add side back, add connection between blocks left, so it will basically take the adjacent block list, and depending on what adjacency is available, we'll call various functions which generate these. Okay, so that's where we're at the moment. I'm going to call this video off here. I'm going to have a good sleep, and I'll be back in a few days with the rest of the video. So thanks for watching, guys. Hopefully we'll get through this pretty quick. It is a little bit tedious going through and numbering all of these things and working out all of the positions, but once it's done, and we never have to do it again. Cool, awesome. Rock on, guys, and I'll see you in the next video. Thanks for watching. Bye.